Alright, in this video, we want to look at trigonometry. Okay, so these are the things we're going to be doing under trigonometry. The first one is what? Trigonometry ratios. Second one is relationship between the ratios. Third one is complementary angles. Fourth one is ratios of special angles. Fifth one is ratios of angles between 0 degrees and 360 degrees. The next one is ratios of angles greater than 360 degrees. The next one is ratios of negative angles, trigonometric equations, and trigonometric what now? Simplification. So this video is going to be in two parts. Okay, we'll cover some parts in this video now, and in this next video we are going to cover the what? The remaining part. So I implore you to watch the video from the beginning to the end. Don't skip any part because this video is going to be loaded. Okay, so the first one is what? Trigonometry ratios. Now, suppose we are given a right angle triangle. What we are going to be dealing with in this video, okay, is a right angle triangle. Under this part of trigonometry, we are going to be dealing with a right angle triangle. So suppose I'm giving a right angle triangle like this. Okay, I'm giving a right angle triangle like this. This part is angle 90. Are you with me? To a right angle triangle, we have three parts and we have three angles. Suppose the angles given are angle A, angle B, angle C, and the sides given, we have side B, side C, and side A. Okay, the side that faces the angle 90 is what we call the hypotenuse. Now, this place is the hypotenuse. Hypotenuse. Why is it the hypotenuse? Because it is facing what now? Angle 90. This symbol, this box, is symbol for angle 90. So this place here is hypotenuse. Suppose I now have an angle here that I call the angle theta. Okay? The side that is facing this given angle is what we call the opposite. This side here, okay, this small c is facing this given angle. That angle can be angle 30, it can be angle 10, it can be any angle. Okay, in as much it is not greater than what now? 90. It should be an acute angle. Are you with me? So this place here will be the opposite. Opposite. Then this last one will now be the what now? Adjacent. So to a right angle triangle, we have three sides. The sides are hypotenuse, opposite, and adjacent. Okay, so under the three ratios, we have 6 of them. We are going to be using an acronym that we call SOCA 12. SOCA 12. Now, class, listen. If I want to solve a question under right angle triangle, it can be done in two ways. If the question involves sides only, I will use what we call Pythagoras theorem. But if the question involves combination of angles and sides, I will use a suitable either of these. Okay, I can use this, I can use this, I can use what now? This, depending on the one that suits the question that I want to solve. So what's our so? Let us go, class. Let's go. So the three ratios we have. So means sine, and sine is equals to opposite all over hypotenuse. So we have opposite all over hypotenuse. Hypotenuse. Then car. This C stands for what now? Cosine. And cosine is equals to adjacent all over hypotenuse. Adjacent all over hypotenuse. And the last one is what we call tua. This T stands for tangent. And tangent is equals to opposite all over adjacent. Okay, these are the what now? The key basic trigonometric ratios that we have. What are they? Sine, cosine, and tangent. They are in form of what now? Ratios. So how do you define them? Sine is opposite all over hypotenuse. Sine of any angle. Sine of an angle is what now? Opposite all over hypotenuse. Cosine of an angle is adjacent all over hypotenuse. Tangent of any angle is opposite all over what now? Adjacent. Are you with me? So we have 6 of them. This is the first one, sine. This second one, cosine. This third one, tangent. So the remaining 3 are just inverse of these. Are you with me? They are inverse of these. Inverse of the ratios. So let me wipe this place off. Alright, so inverse of the ratios. The first one is inverse of sine. 1 over is meaning of inverse. Inverse of sine is what we call cosecant. Please don't forget. Then the inverse of cosine is what we call secant. Then the inverse of tangent. The inverse of tangent is what we call cotangent. So these are the meaning. Inverse of sine is cosecant. Inverse of cosine is secant. Inverse of tangent is cotangent. Are you with me? I will now give you the what now? The abbreviated versions of all these ratios. So it means for this cosine, instead of having opposite all over hypotenuse, it will be hypotenuse all over opposite. I think you understand what I'm saying now. Inverse is what now? Just what now? Transpose it. Some will go up, some will come down. So for secant, instead of having adjacent all over what now? Hypotenuse for cosine, it will now be what now? Hypotenuse all over what now? Adjacent. Then for tangent is what now? Opposite over what now? Adjacent. But for cotangent, it will be adjacent all over opposite. So these are the ratios that we have under trigonometry. So let me just give you what now? The abbreviated format of all these ratios. So let us go, class. Let us go. So the first one, the ratios. Then abbreviated what now? Form. So cosine, sine is abbreviated as what now? Sin. Cosine is abbreviated as what now? As cos. Tangent is abbreviated as what now? As tan. Cosecant, let's see cosec, okay, or they say CSC, cosecant. Are you with me? Then secant, we have very secant as what now? Sec. Then cotangent, we use what now? Cot. So anytime you see all these things, these are the what now? Abbreviated what? Abbreviated format of the trigonometry ratios. So 3 ratios. Okay, so we have sin for sine, we have cos for cosine, we have tan for tangent, we have cosec or CSC for cosecant, we have sec for secant, we have cot for cotangent. What is cosecant? Cosecant is the inverse of what now? Of sine. What is secant? Secant is the inverse of what now? Of cosine. That is 1 over. Then what is cotangent? Cotangent is the inverse of what now? Of tangent. As I told you, I said questions under right angle triangle can be solved in 2 ways. Okay, depending on the parameter supplied. If the parameter involves sides only, I will use Pythagoras what? Theorem. Then if the question involves combination of side and angle, I will use this what now? This ratio is suitable what now? A suitable ratio. So let's take some what now? Some questions. Before we do that, let us take Pythagoras theorem. Let us take Pythagoras. You can pause the video and write the word now and write this abbreviated version of the ratios down. So let me take what now? Pythagoras theorem. So it means in rectangle triangle, we will see Pythagoras theorem being used. And in rectangle triangle, we will see SOHCAHTOA being used. We use these two rules specifically to a right-angled triangle. And what is a right-angled triangle? It is a triangle like this. I think you understand what I'm saying in class. Please try and understand though. This is angle 90. So anytime you see a triangle like this, okay, it is called a right-angled triangle. This boss is 90 degrees standard. Alright, so we have A here, we have B here, we have C here. This is our what now? Our small b. This is our small a. This is our what now? Small c. Pythagoras theorem now. Let us go, class. Pythagoras theorem states that what now? My hypotenuse all squared is equal to the sum of the opposite side, opposite squared. I'm talking about side here. And what now? Adjacent squared. Adjacent what? Squared. This is what we call Pythagoras theorem. Side, and what now? And side. So what's our hypotenuse? The side that faces the angle 90. So I can put B all squared is equal to, where is the opposite? If I put my angle here, class, if I put my angle here, this will be my what now? My opposite. I said opposite is the one that is facing the given angle. This is 90 standard. So an angle will be given here or here. If the angle is given here, this will be our what now? Our opposite. But if the angle is given here, this will be our what now? Our opposite. So suppose the angle is given here now. Are you with me? This will not be what now? Opposite. So we're having what now? A as the opposite side. How will not be what now? A squared plus, this will be our adjacent now. C squared. This is what now? Pythagoras theorem. I said we use this theorem to solve question on a right angle triangle if the question involves just side, and side. If the question is talking about what? Side, and side. But when the question involves angle and what now? And side, we use SOHCAHTOA. Let me solve some questions so that you understand what I'm trying to say. So let us take this diagram. You can pause the video, write the two things down, what I've explained now. Those two things are what I'm going to be using to solve question under right angle triangle. I repeat, class, this aspect of trigonometry is all about right angle triangle. We can solve question under right angle triangle in two ways, depending on the data supplied. If the data supplied, that is, data given to that right angle triangle are just side, I will use Pythagoras theorem. But if the question involves side and angle, I will use a suitable what now? Ratio, meaning our SOHCAHTOA. Is it clear? So let us go. Let's solve some questions. So the first one, we have this. Let me just give you the diagram straight. So we'll now be taking it one by one. So look at the diagram that we're given. So we have to find the what now? The letter, missing letter. This is a rectangle triangle. Here we are given x, we are given 4, we are given what? 3. The second one, we have this. We are given a here, we are given 13 here, we are given what here? We are given 12. And the third one, we have this. We are given y here, we are given 17 here, we are given what now? 15 here. Now look at this last. This question involves what now? Side. Oh, you see it? Side. I'm given two sides. I'm asked to find the third side. Two sides, the third side. Two given side and third side. Just sides only. In this case, because it involves side, and side, I'm going to use what now? Pythagoras theorem. So let us go. The first thing, you state the theorem first. So this first one, we have hypotenuse all squared, the theorem. So you won't make mistake. is equals to what? Opposite all squared plus adjacent all squared. So where is the hypotenuse? The side that is facing the angle 90, which is x here. So we'll put what? S all squared here is equals to, I can choose anyone as what now? As opposite. Anyone. So let me choose this. So I have what now? 4 squared plus adjacent is what now? Is 3 squared. So we have our s squared is equals to 4 squared is 16 plus 3 squared is what now? Is 9. So our s squared will be equals to what now? 16 plus 9 is 25. So ordinary s will be equals to the root of what now? 25. And this will give us what now? 5. So it means our x here is 5. This one too contains side. So I'll still use what now? Pythagoras theorem. So here, where is the hypotenuse? 13 in this case. See, 13 is the hypotenuse here. S is the hypotenuse here, is the unknown. But here, 13 is what now? The hypotenuse. So we have what? 13 all squared. A is the opposite. I'll put what now? A all squared plus 12 is adjacent. I'll put what now? 12 all squared. Like I told you, 12 can be the opposite. A can be the what now? Opposite. 12 can be the adjacent. A can be the adjacent. Depending on the angle given. If the angle is here, 12 the opposite. If the angle is given here, A is the opposite. Are you with me? So what are 13 squared? That would be 169 is equals to what? A squared plus 12 squared is what now? 144. In this case, we are going to collect like terms. This one will come here. Now 169 minus 144 is equals to what now? A squared. What is 169 minus 144? We have 25. 25 equals to what now? A squared. So the same thing now. What's our A? That will be root of 25. A will be root of 25. Root of 25 is equals to what now? A. So ordinary A will be equals to what now? 5. Okay? So that is what you have here. So our A is what now? Is 5. Then for this last one, we have, where is the hypotenuse? Correct. 17. So we have what? 17 squared. 17 squared is equals to, I can say y squared as the opposite plus 15 all squared. So what do we have here? This is 289. It's equals to y squared plus what? 225. So we collect like terms here. So having our y squared, let me write this piece off. Having our y squared, y squared will be equals to what? 289 minus 225. So y squared will give us what now? 464. Ordinary y will be the root of what now? 64. And that will give us what now? 8. I use Pythagoras theorem to solve all these questions because it involves sides. Are you with me? It involves sides. So you can pause the video and see the way I solve the question. Now, if question involves side and angle, okay? So what we see out this here, let's solve 2 questions. Side and angles. What are we going to do? Alright, so this one is 30, x and 8. This one is x, 30, and this one is what now? Is 8. Then second one is 60, y 10. Y is here, 60 is here, and 10 is here. Okay? And third one is what now? 45, 5k. 45 is here, 5 degrees. Then k is down here. K is down here. And we're given what now? 5 here. Class. This question involves what? Combination of what now? Angle and side. You see it? Angle and side, angle and side. So I'm going to use a suitable what now? Trigonometric ratio. Which one will I use here? S is opposite to this 30. So I'm having opposite. 8 is the hypotenuse side. I'm having what? Hypotenuse. So what would I use to finish this thing up? Okay? To make it to be a what now? A trig ratio. What would I have to it? I want what now? X. So that is so. That's the way we work now. We determine the one to use. I have opposite as x unknown. I have x as the hypotenuse. So to combine it, I'll put x here so that to be complete. So I'm having sine. So sine of 30. Sine 30. What's the meaning of sine? Opposite. X hypotenuse 8. So what's the next thing? I will cross multiply. So our S will be equal to what now? 8 times what? Sine 30. And that will give us what now? 8 times sine 30 is 0.5 or 1/2. So this will give us what now? 4. So our S is what? Our S is 4. This case here, this one is opposite. It's not given. But here we have adjacent. Opposite, adjacent, and what now? So I have adjacent and hypotenuse. Okay? So what will I do to complete this thing? I will use what now? My car. Are you with me? So I have car. Here, so you are saying that what now? Cos 60 equals to adjacent. Y all over hypotenuse is what now? Is 10. I will cross multiply. Y will be equals to what now? 10 times what? Cos 60. Now we are having 10 times cos 60 is 1/2 or 0.5. I'll tell you how we'll get all this what now? All these ratios. We'll call it what now? Ratios of special angle. When we get there, I'll tell you how to get all the ratios. So 10 times what now? 1/2. This will give us what now? 5. So our y is what? Our y is 5. For the third one, this is the opposite. 5 is the opposite to 45. Then k is what now? Is the adjacent. So I'm having opposite and what now? Adjacent. So what I need to complete this? I will use what now? 12. Okay? So we are saying tan 45 for the third one. Tan 45. What is tan? Opposite. 5 all over. Adjacent is what? K. So what's the next thing? We'll cross multiply. So having k times what? Times this. We have k times tan 45 is also what now? 5. The next thing we divide both sides by what now? Tan 45. Tan 45. Tan 45. This one will cancel out this. So our k will be equals to 5 all over tan 45 is 1. So our answer here is equals to what now? 5. I've solved both cases. I told you that we can solve question under right angle triangle in 2 ways depending on the data supplied. If the data supply or if the question involves sides only, we'll use Pythagoras theorem. I've explained that. Then if the question involves combination of side and angle, like the ones we have here, we use a suitable what now? Trigonometry ratio. Are you with me? Now, sometimes you'll be given a particular ratio. You'll now be asked to find another ratio. I repeat, sometimes a question will be, you'll be given a particular ratio, you now be asked to find what now? Another ratio. So in this case, let us solve question. Question that involves a ratio given and will now be asked to find another ratio. Question that involves a ratio given and being asked to find another ratio. Being asked to find another ratio. So we have something like this. Let's take jump question. Jump question. Now, before I solve that, anytime you are given a particular ratio and you are being asked to find another ratio, the first thing to do is draw a right angle triangle to show the effect of that given ratio. What do I mean? Look at this. 2016 jump question. One says if sine theta is given as what now? As 12/13. See, this is the given ratio. We're asked to find the value of 1 plus cot theta. 1 plus cot theta. We're now given the options. We have 5/13. B, we have 12/13. C, we have 25/13. And D, we have 8/13. Alright, so in this case, a ratio was given. We're now to find another ratio in form of what now? Basic algebraic what now? Expression 1 plus. Okay? Alright. Now look at this. Sin theta is given as what now? 12/13. And I said anytime you are given one ratio, draw a right angle triangle to show the effect of that ratio. So I will first draw a right angle triangle here. Okay? Draw a right angle triangle here to show the effect. So theta is here. What is sine? sine is opposite all over hypotenuse. So it means sine is 12 over 13. What's the meaning? This is the opposite. This is what now? Hypotenuse. Because sine is what? Opposite all over hypotenuse. So it means our 12 is the opposite. And 13 is what now? Hypotenuse side. Where is 13 here? The side that faces the angle 90 is hypotenuse. So I'll put what? I'll put 13 here. Then the side that faces the given angle is what now? Is opposite. I'll put 12 here. So I need this side. Because I call it what now? 8. Class. When I have two sides given, and I have been required to find the third side, we are going to use Pythagoras theorem. So I'll say the theorem. Hypotenuse all squared equals to what now? Opposite all squared plus adjacent all squared. Where is the hypotenuse? 13 all squared is equals to opposite is 12 all squared plus s all squared. What is this? 169 equals to what now? 144 plus s all squared. The correct items we have 169 minus 144 is equals to what now? S all squared. So this will be 25 equals to what now? S all squared. Our s will now be what? The root of what now? 25, which will give us what now? 5. Beautiful. We'll also find 1 plus cos theta. 1 plus cos theta. Cos theta. So here, what is our cos? Cos is adjacent. You know that cos is what? Adjacent all over what now? Hypotenuse. So from here, where is adjacent? Our s, which is now equals to what now? 5. So we'll now be having 5 all over. Where is the hypotenuse? 13. So our cos, okay, cos theta, cos of the angle. Cos theta equals to what now? 5 all over 13 from this triangle. So we'll now be having 1 plus, you see it? 1 plus 5 all over what now? 13. What's the LCM? 13. 13 in 1, 13 times 1, 13 plus 13 in this one, 1. 1 times 5, 5. So 13 plus 5 will give us what now? 18. This is 18, not 8. It should be 18. Not 8 class. So this should be what now? 18 all over what now? All over 13. This should be 18. This should be 18 over 13. So that is what we have here. Okay? It should be 18 over 13. Alright, so let us repeat this. This is 13 plus 1, 18 over what now? 13. So this is the solution. Here, we are given a ratio. We now have to find another ratio. So anytime we are given a ratio, find another ratio, the first thing, like I repeat, is to draw a right angle triangle to show the effect of that what? Ratio. Let's solve one more question under this. Let's solve one more question under this. 2010. 2010. 2010. 2010. 2010. We're given cos theta. Good. Just says 2010. 2010. If cos theta is given as 8 over 15. 8 over 15. Where theta is acute. Where theta is acute. Theta is acute. Meaning it is between what now? 0 and 90. It is greater than 0 but less than 90 degrees. These are acute angles. Find sin theta. We now also find sin theta. Find sin what? Sin theta. So I told you, I said if a ratio is given, the first thing to do is what now? Draw a rectangle triangle. Okay, so solution. That's the format, class, please. That's the format. You are given a ratio. Draw a rectangle triangle first. So we have a rectangle triangle here. This is theta. This is cot. Are you with me? What is cot? Look, cot is the inverse of tan. Inverse of tan. Are you with me? So tan itself, tan theta is opposite all over what now? Adjacent. So it means cot theta will be adjacent all over what now? Opposite. Okay? If you check the table I gave you initially. So it means our what now? Our 8 is adjacent. 8 is adjacent. Then 15 is what now? Opposite. 15 is opposite. So Where is the opposite side? The side that faces the given angle. This will be 15. Okay. And where is the adjacent? This will be what now? 8. Tan is opposite all over adjacent. Cot is the inverse of tan. Then that will not be what now? Change it. Adjacent all over what now? So here we have, suppose we are given x, we need this third side. So when question involves side, we use Pythagoras what theorem. So here we have our hypotenuse all square, which is what now? S all squared is equals to 15 all squared opposite plus 8 all what now? All squared. So what is 15 all squared? 225 plus what is 8 all squared? 64. This will give us what now? 289, I suppose. Yes, 289. 289. So this is our x, s squared, s squared. Ordinary s will be what? The root of what now? 289. And that will give us what now? 17. But now to find sine theta. Sine is what now? Opposite all over hypotenuse. Opposite all over hypotenuse. So where is our opposite? S, which is what now? 17. That will now be 17 all over. Where is the, sorry, opposite is what? Is 15, sorry. Opposite is 15. Opposite is 15. 15 all over. Where is the hypotenuse? We have 17. The correct answer is what now? 15 all over 17. Let me give you the options here. We have A. We have A. Option A. We have 6 over 17. 6 over 17. We have B. 13 over 15. We have C. 8 over 17. And we have D. 15 over 17. So the correct answer to that question is 15 all over 17. So we are done with the first phase, which is what now? Trigonometric ratios, and we'll solve questions on them. Second phase is what we call relationship between the ratios. Relationship between the ratios. As in, what exists between the ratios? We know the ratios of what is the relationship between what now? Between them that we can establish. Okay? Relationship between the ratios. So let us go for the relationship between the ratios. Alright? The first one here. Let me wipe this one off. You can pause the video. Okay? Pause the video and see the way we solve the questions. This relationship between the ratios is what we call basic identities. Basic identities. Relationship, we can call it basic what? Identities. Basic identities. Alright, so class, let us go. Basic identities. What's the meaning of basic identities? Let us go back to the right-hand triangle. So I'll be able to tell you why this thing is like this. So this is our what? Our theta. This is our A. This is our B. This is our C. Big sides. Big. They are what now for angles? They're small letters for side. This is what now? This is A. Before I tell you all the identities, let me show you something. So class, from here, what is sine theta? Sine theta will be equal to opposite C all over hypotenuse B. That one is clear. What is cos theta? Cos theta is equal to what now? Adjacent. Where is our adjacent? A all over. Where is our hypotenuse? B. And what is tan theta, class? Tan theta is equal to what now? Opposite C all over adjacent A. Now, the first basic identity is this. The first one. We have 4 of them. I will list all the 4, but I will tell you how they got all the 4. The first one is what now? Here, class. What is sine all over cos? Let us get some part here. Sine theta all over cos theta, what will it give us? It will be sine C all over what now? B divided by what is cos? A all over what now? B. So I'll change to what? Times. So we have C all over B times B all over what now? All over A. B will cancel out B. So we have what now? C all over what now? A. What is C all over A? It is tan theta. You see it? So it means the first ratio is for every tan something. For every tan theta, I must have sine of theta all over cos of theta. That's the first basic one from what I did here. okay, from this ratio. Sine over cos is C over A. And what is C over A? Tan. So that's the first what? Basic identity. If I square sine, I square cos, and now add them together, I must have 1. I must have 1. Let us go. Let us go. So what is cos square theta? Cos square theta will be equals to A all over B all squared. Cos square theta is same as saying cos theta all squared. Same thing. Okay, so what's cos theta? A all over B all squared. This will give us what now? A squared all over B squared from indices. Okay, I'll open the bracket, I'll have this. What is sin square theta? That will be C all over B all squared. If I open this bracket, I'll have what now? C squared all over B squared. C squared all over B squared. Let us now add them together. Let's add cos square theta to sin square theta. Let us see the result that it will give us. Okay? Let's see the result that it will give us. So cos square theta plus sin square theta, what will it give us? A squared all over B squared plus C squared all over B squared. So what do I have here? We have B squared. This will be what? A squared plus B squared. Plus, what is A squared plus B squared? This is A squared plus C squared. A squared plus C squared. So what is A squared plus C squared from Pythagoras theorem? What is Pythagoras theorem here? That would be B squared hypotenuse squared. I mean, it's also what now? Opposite squared. I can write it anyhow. I can say what now? A squared plus what now? Plus C squared. Are you with me? So B squared equals to what now? A squared plus C squared, or B squared equals to what? C squared plus A squared are the same thing. Addition is commutative. 2 plus 3 is 3 plus 2. Because some people will say, shebi the opposite is what? Is C. B squared hypotenuse squared is equals to what now? C squared plus A squared. This one and this one, they are the same what now? Thing. I'm using Pythagoras theorem here. Pythagoras theorem here. Pythagoras theorem. Or Pythagoras rule. So which implies our A squared plus C squared will give us what now? B squared. So here will now be B squared all over B squared. What is B squared over B squared? That is 1. So it means another basic identity that we call relationship between what now? Ratios is for every cos square of an angle plus sine square of that angle, our answer must be equals to what now? It must be equals to 1. So let me write the next one. Let me write the next basic identity. So second one, let me write it full so I'll be able to see what we're doing. Okay, let me write it full. Write it full so I'll be able to see what I'm doing. So second basic identity, cos square of something plus sine square of that thing must give us what now? 1. It must give us 1. So what's the next thing now? I will now work on this. This is the first basic identity. This is the second word now, basic identity. What's the third one? If I now divide this equation 2 by cos square, let's just see what will happen. Divide equation 2 by, let us see, okay, let's use sin square theta first. We now come back to use what now? Cos square theta. So we'll now be having cos square theta all over sin square theta plus sin square theta all over sin square theta equals to what now? 1 over what now? Sin square theta. I want to divide through. I'm dividing equation 2 by what? Sin square theta plus sin squared something over sin squared of that thing. This will give us what now? 1. Look at this one. Look at this. We know that tan theta is sine over cos. If I now put square here, what will happen? This will become what now? Squared. So I'm saying our tan square theta it must give us sin square theta all over cos square what now? Theta. That's a fact. But in this case, I'm having cos on top, sine down, which is the what now? Inverse of this. So 1 all over tan square theta give us what now? Cos square theta all over sine square theta. If I change it, the reciprocal. The inverse of tan is cot. What is now the inverse of what now? Tan square theta. That will be cot square. This one give us cot square theta. I hope you understand what I'm trying to explain here. Because inverse of tan, inverse of tan, inverse of tan, 1 over tan is cot theta. Is cot theta. What will now be 1 over tan square theta? Just give us what now? Cot square theta. Is it clear? So it means this space will be cot square theta. Then what is 1 over sine? 1 over sine is cosec theta. 1 over sine, inverse of sine is cosec theta. What is now the inverse of 1 over sine square theta? That will be cosec square theta. So this one becomes cosec square theta. This is the third word, basic identity. I have showed you how they got that. So the third one is, I'll put it here now. So what's the third one? Third basic identity. We have 4 of them. So the third one, 3. We have cot square theta plus 1 must give us cosec square theta. That is the third one. Then the fourth one, this is my equation 2. You know, I divided equation 2 through by what now? By sine square theta. Let me now divide it through by what now? By cosec square theta. Divide equation 2 through by cos square theta rather. So this one becomes cos square theta all over cos theta plus sine square theta all over cos square theta equals to what? 1 over what now? Cos square theta. This one equals 1. 1 plus. What is sine over cos? Sine over cos is what? Is tan. But sine square over cos square equals what now? Tan square theta. Inverse of cos is sec. What is now the inverse of what? Sec square theta. It will not be what now? Inverse of cos. Inverse of cos is sec. Inverse of cos is sec. What is secant? What is now the inverse of what now? Cos square theta. That would be sec square theta. Sec square theta. Sec square theta. So that is the fourth basic word now, identity. I hope you understood what I did here. 1 over cos is sec. 1 over cos square will be sec square. As simple as what? As that. So let us write the fourth basic identity and let's use them to solve what now? Question before we go to what we call complementary angles. Complementary angles. So the fourth basic identity is for every 1 plus tan square theta, I must have sec square theta. So these are the 4 basic identities. What's the first one? First one is what? Tan theta equals to what now? Sin theta all over cos theta. And these are the remaining ones. Cos square theta plus sin square theta equals to what? 1. Third one, cos square theta plus 1 equals to cosec square theta. And the fourth one, 1 plus tan square theta equals to what now? Sec square theta. What is the inverse? What is the meaning of cosec? Inverse of sine. What is the meaning of sec? Inverse of what now? Of cos. I think we've done that. That was the first thing we did in this what? In this video. So let us see the way they use this ratio. okay, in question. Let's see the way we use these ratios in question. So let me wipe all these ones up. Then we've written them down. So here we are given that cot theta equals to 12/13. Find, so they say given that cot theta equals to 12/13, 12/13, find what we got 1 sin square theta plus cos square theta, what we got 2 1 plus tan square theta, what we got 3 cos square theta plus 1. Okay, so we have this, and I told you anytime we are given the ratio, one of the trigonometric ratio, if the values are given, draw a right angle triangle. Once the values are given in form of fraction, draw a right angle triangle to see the effect of that what now triangle, like I told you. So let us go here. So the first thing, I'll put this in here, I won't wipe it off. So the first thing, I'll draw a right angle triangle. If I put my theta here, anywhere I want, this will be the opposite. This is still what now? Cos is adjacent all over hypotenuse. Okay? So where is my adjacent? This will be our adjacent. This will be the opposite. Adjacent is what? Is 12. Hypotenuse is what now? Is 13. So I'm looking for what now? The last one. Opposite is what? This is x. When question in both sides, we use Pythagoras theorem. So let us solve this. Hypotenuse all squared of 13 squared is equal to opposite all squared, that is s all squared, plus adjacent all squared, that is 12 all squared. This will be what now? 169 equals to what? S squared plus what? 144. 169 minus 144 equals to what now? S all squared. So this will be what now? 25 equals to what now? S all squared. Ordinary s will be equals to what now? The root of what? 25. And this will give us what now? 5. So our s is what now? Is 5. Isn't it? Our s is 5. Beautiful. What's the first thing? Is a fact. Sin squared theta plus cos squared theta must give us 1 is a fact. You can show that. But in the exam, if it's OBJ, just pick your answer. 1 is the answer. 1 is the answer. But in theory, show them how you got your answer. But this is going to give us 1. Confirm. It's going to give us 1. So let us go. What is now sin squared theta? Sin squared theta plus cos squared theta. What is sine? Sin theta will be equal to what now? Opposite 5 all over hypotenuse 13. Then for the square now, square of this one will now be 5 over 13 all squared plus what is cos square theta? That will be 12 over 13 all what now? All squared. Like I told you, sin square theta is the same as saying what now? Sin theta all squared. Cos square theta is the same as saying what now? Cos theta all squared. So this is affecting both. 5 squared is 25. 13 squared is what now? 169. Plus 12 squared is what? 144 all over. 13 squared is what now? 169. We find the LCM. What's the LCM? 169. This will be 25 plus 144. What's 25 plus 144? 169 over 169. And that gives us what now? 1. You see that? It gives us 1. If it's OBJ, just pick what? Just pick 1. But if it's theory, show them what you have. Show them the stuff you are made of. So next one is 1 plus tan square theta. This one you can solve it. You find your tan square theta first. You add 1 to it, or I can use this one. It means what I'm asked to find here, it's same as saying what now? Sec square theta. Are you with me? It's same as saying sec square theta. And what is that? Sec is the inverse of cosine. So it means our answer will be 169 over 144. That's the meaning. Because sec is the inverse of what? Of cosine. But here is sec square theta. That is inverse of what now? Cosine, cos square theta rather. So that inverse is what we change it. Let me just solve the question so you understand what I'm trying to say. Let me wipe the basic identity off. I think we have them in our brain now. Right now should be in our brain. Should be in our brain. So let us go. Let me solve it. Let's solve question number what now? Number 2. We have to find 1 plus tan square theta. And we know that what now? Under the basic identity, 1 plus tan square theta is equals to what now? Sec square theta. I can solve this question in 2 ways. Either I solve it like this, or I use what now? By my basic what? Identity. So if you want to solve it like this, we know that what now? Our tan theta is what now? 5/12. Okay? Let's go. So 1 plus tan square theta will be equals to 1 plus 5/12. Everything is power what now? 2. So now be 1 plus 5 squared is 25 all over 12 squared is what now? 144. This will now be what now? 1 plus, what's the LCM? The LCM is what? 144. Okay. This will now give us what now? 144 plus what? Plus 25. 144 and 144, 1. 1 times 25 is 25. We now have what now? 169 all over 144. That's the first way to solve it. We want to use what now? Basic identity. 1 plus tan square theta will give us what now? Sec square theta. I think you know that. Okay? If we want to use what now? Our knowledge of what now? Basic identity. Let us go for basic identity. So you can solve the question in 2 ways, like I said. So 1 plus what? Our 1 plus tan square theta is equal to what now? Sec square theta. And sec square is the inverse of what now? Of 1 over cos square theta. Okay? Sec is the inverse of what now? Cos. Isn't it? So what do I have here? What are our cos theta? Our cos theta is 12/13. 12/13. And our cos theta is what now? 144 over what now? 169. So our cos theta is what? 12/13 all square, which will go to what now? 144 all over what now? 169. So the inverse of it will now be what now? That will be 169 over what now? 144. The same way. Okay, so it means our sec square theta, which goes to what now? 1 over what? Cos square theta will now be equal to what now? 169 all over what now? 144. Which is what we have here, the same thing. Is it clear? Same thing. So we have the same what now? The same result. So that is that on what now? On that. So the third one, we have what now? We have cos square theta plus 1. Cos square theta plus 1 will give us what now? Cosec square theta. So let me just use that one straight. Cos square theta plus 1 is just what now? Cosec square theta. From my basic what now? Identity. And cosec is the inverse of what? Inverse of sine. Inverse of sin square theta. So I need to get what? My sine. Sine square theta is 25 over 169. So sine square theta is 5/13 all square, which is just what now? 25 all over 169. What will now be cosec square theta? That will now be what now? 169 all over what? 25. I can solve it like that. Or I just say find the value of cos square theta, add it to 1, and we have the same what now? The same what result. So that is that on what? Relationship between what now? The ratios, or what we call basic identity. So the next one, okay, which is very, very important, is complementary angles. Complementary angles. Complementary angles. Complementary angles. What are complementary angles? Complementary angles are angles that add up to give what? 90 degrees. Complementary angles. Complementary angles. Complementary angles. These are angles that add up to give what now? 90 degrees. Angles that add up to give 90 degrees. So we have some facts under what now? Under complementary angles. Take it of these. We have some relationship under complementary angles. Relationship under complementary angles. What's the first one? For every sine something, so for sine something, sine theta, we must have cos of 90 minus theta. That's the first relationship, which is the part. Second one, for every cos something, we must have sine of 90 minus that thing. That's the second one. Then third one, for every tan something, we must have cot of 90 minus that thing. And the fourth one, for every cot something, we must have tan of 90 minus what now? That thing. Now, for example, let me take the first one as example. Let's assume our theta is now what now? Is 30. Mind you, we said complementary angles are angles that add up to give what now? 90 degrees. So if you are being asked to find the complement of 30 degrees, that would be 60, because 60 plus 30 will give us what now? 90. If you are being asked to find the complement, for example, complement of 20 degrees, that will be 70. It means what is the value of angle that I will add to what now? 20 to give what now? 90, which is what now? 70. So that's what we have under complementary angle. So let us take this one. These are facts. Relationship under what now? Complementary angles. You can pause the video and put all these down. So let us assume our theta is 30. Let's assume our theta is what? Is 30. Let us see, is it true? So this we are having what now? Sin 30 equals to cos 90 minus what now? 30. Okay, so this will now be sin 30 equals to what now? Cos what? Cos 60. So when you press sin 30 calculator, you have 0.5. When you punch cos 60, you have 0.5. So it means this is what now is very correct. Okay, so how do you use this one to solve question? Please take note. If you say 30 plus 60, look at this. 30 plus 60 will give us what now? Nice. That's another way to know whether you are correct or what or not. You must have different identity here, different trigonometric ratio rather. Sine is here, cos is here. 30 plus 60 is 90. And I can have cos here, sine here. 30 plus 60 is what now? Is 90. So how do we use this concept to solve what now? Questions. Let us go. Let's go. So just note that what now? We have this relationship under complementary angle. So let us go and solve questions today. I'll list the questions out and we'll solve them one by one. The first one is look at this. Good. I like this question. We are given we have to find the value of the letter. Find the letters or the alphabet. Find the alphabet. Let's say alphabet. The first one, we are given cos y sin theta is equals to cos 3 theta. Second one, we are given sin 3k minus cos 2k equals to 0. Then third one, we are given cos y equals sin y plus 22. So how do we solve this? We now have one question under what now? Under what do you call it? Jam. Look at the way they ask us. This is 1980. Question 47. Jam question. Question says if sin theta equals to root 3 over 2 and theta is less than 90 degrees. Calculate tan 90 minus theta all over cos square theta. And we're given the options A, root 3 over 2, B, 4 over root 3, C, 4 root 3, D, 2 root 3, E, 1 over 2. So let us go, class. Now, the way we solve question under complementary angle is this. Whenever I see a question in mathematics that has two different what now, basic trigonometry ratio, sine is here, cos is here, and they are now being separated by what now, equality sign or sign of equality. It means this type of question is going to be solved using our knowledge of complementary angles. Sine is here, cos is here, equality sign, and we use complementary angle. Look at this one too. Cos is here, sine is here, and we use complementary angle. Even this one too, sine is here, cos is here, because this one will go here to become plus. You have to be very careful. So with the first one, solution to the first one, we have sine theta equals to what now? Cos 3 theta. This should be sine 2 theta. So, okay, sine theta, let's go. Let's go. Now, what do we have here? It is either we change this one to cos, so that we have cos here, and at the end of the day, the cos will cancel out, or we change this one to sine, so we can have sine here and sine here, then the sine will cancel out. So the basic idea under complementary angle is this. I will change this ratio, make them to be the same thing. That's all. And they will cancel out later. So here, I know that sine something, this one here, is very easy to change to what now? To cos. Sine something will give us what now? Cos of 90 minus that thing. Is it not? From the what now? From the relationship. This one is the same as this. It's just what now? Cos what? Cos 3 what now? Theta. So what happened? Cos will cancel out what now? Cos. And I have 90 minus theta is just what now? 3 what? 3 theta. Theta will come here. We have 90 is just what now? 3 theta plus what now? Plus theta. So what do I have here? 90 is just what now? 4 what? 4 theta. So what do we have our theta? What do we have theta? Theta will be just what now? 90 over what now? All over 4. What does that give us? Here, 4 here, we have what now? We have 1. 4 here, we have 2 rather. We have 2. 4 in 8, we have 2. Remainder what now? Remainder 1. 4 in 10, we have what now? 2 again, then point. Then 4 in 20, we have 5. So 22 point what now? 0.5. 22.5. That is the final result. So 4 here, 4 in 9, we have 2, that is 8. 4 in 10, we have 2, remainder 1. Then, how is this correct? 4 here, 2, 8, carry 1. 4 in 10, we have 2, carry 2. Then 4 in 20, we have what now? We are very correct. 22 point what? 22.5. So the final answer here is 22.5. That's it for the first one. So now, looking at the second one, class, what do you think will happen? This one here, I have sine here, I have cos here. What would I going to do? I will just make sure that it forms what now? An equation. I will make sure that it forms an. Look at the way I solve this one. I use my knowledge of what now? Complementary angle. So let me see the second one. So here, sin 3k minus cos 2k equals to 0. So what I'm going to do, this one to this side. So I'm having sin 3k is equals to what now? Cos what? Cos 2k. You see it? It's as simple as that. So what I'm going to do, I will now use my what now? My basic understanding of what now? Of complementary angle. Because I have sine here, I have cos here. You see it? And I have equality sign between them. That is the rule. So I'll change this one to what now? To cos. Or I change this one to what now? To sine. Let me change this one to what? To cos. So you know that recall that sine something is equals to what now? Cos of 90. Now that thing. Be careful here. What we have here is now 3k. So it means sine 3k Sin 3k give us cos of 90 minus 3k. Take note of that. We want to change this one to what now? To cos, to the cos 90 minus the whole angle here, which is 3k. The angle here is 3k. So this one becomes what? Cos 90 minus what? 3k equals what now? Cos what now? 2k. Cos will cancel out what now? Cos we now have 90 minus 3k is equals to what now? 2k. This one will come here. We have 90 equals to what now? 2k plus 3k. What that one give us? 90 will give us what now? 5 what? 5k. So our k only give us what? 90 all over what now? 5. And that will give us what now? 5 here. 1 in 40, 18. Well, our k is what now? Is 18. We can confirm. But do you know we can confirm class? How do you confirm? This is 18. If I put 18 here, we're having 3 times 18, right? And if you put 18 here, I'm having what now? 2 times 18. What is 2 times 18? 36. So I'm having this one will be cos 36. What is 3 times 18? That will give us what now? 54. 54. 54. So sin 54. 54 plus 36. That is what now? 90. Just to confirm that we are correct. So because when you add the two angles together, you must have what? 90. That is the idea behind what now? Complementary. I hope this concept is clear. Okay, for complementary angles, you are going to be changing. You change. This one is sine, cos. Change them to cos. So that I can have cos and cos here. So our cos will cancel out. Or I change one to sine. So I can have sine here and sine here. Then sine will cancel out. So let's take the third one. Let's take the third one. Before we move on to the what do you call it? I think the next one is okay, I'll do equation, trigonometric equation, and simplification. Then the next video I will do ratios. Ratio of special angles, ratio of angles between 0 and 360, then ratio of angles greater than 360, negative angles. So I'll use that second video to do what now? All the ratios. But in this case, after this one, we'll take what now? Trigonometric equation and trigonometric what now? Simplification. Okay? So and we'll call it what? A day. We'll call it a day. So let's solve the third one. Let's solve the third one. You see questions like this every year. Okay, can I explain them? You see them in past question. See them in past question. So the third one, half cos y equals to what now? Sine y plus 22. I think by now you should be able to know what I'm doing. I'll change it to sine. So this will now be sine 90 minus y. Okay? Cos y will give us sine 90 minus y. It's equals to what now? Sine y plus what now? 22. So what happened? Sine will cancel out what now? Sine I have 90 minus y plus what now? Y plus what now? 22. What's the next in class? I will collect what now? Like terms. This one will go here. This one will come in. So I'm now having 90 minus 22 is equals to what now? Y plus what? Plus y. What do I give us? This is what now? This is 8. This is 68. Is equals to what now? 2 what? 2y. So what is the next thing? Our y will be equals to what now? 68 divided by what now? By 2. So we now have our y to be equals to what? 68 divided by what now? By 2. And that will be also 34 degrees. I can confirm, like I told you. But you put 34 here. This will be 34 plus what now? 22. What is 34 plus 22? That will be 50 what? 56. 56. I mean 56. 56. 56. And this is what now? 34. 34 plus 56 will give us what now? 90. So we are very correct. Okay? That's how to confirm. Put the given value, what you got, back into the what now? The equation. What is y? Y is 34. If I put 34 here, when you press cos 34, you must have what now? Sin 56. Because this one is y plus 22. Now y is 34. 34 plus 22 will give us what now? 56. So when you punch cos 34, you must have what now? Sin 50 what now? The same value. Sin 56. So that is that. That. So the last one is what now? I told you, anytime I given this, we first draw what now? Right angle triangle. But in this case here, what is tan 90 minus theta? That will be cos theta. That will be cos theta. Let us simplify this one first. Let us simplify this one first. So you understand what I'm trying to say. So let me simplify the angle first, the given question, before I now substitute. So I have tan 90. Tan 90 minus theta all over cos square theta. What is tan 90 minus theta? That will give us what now? Cos theta all over cos square theta. Are you with me in class? And cos is the inverse of tan. You know that cos theta is equals to 1 over tan theta, which is the same as saying what now? Cos theta all over sin theta. We know that tan theta is sin theta all over cos theta, isn't it? So what's now be 1 over tan theta? I'll just change it to be cos theta all over sin theta, meaning I was what now? Swap it. This one go up, this one comes down. So I have this. Is that okay? So I have this. So it means what I'm having here. What I'm having here. So my cos theta all over cos square theta is the same thing as saying what now? Cos theta all over sin theta divided by cos theta all squared, meaning cos square theta. Can I continue? Are we together? Cot over cos square theta. Cot is this divided by, so what do I have here? We have having cos theta all over sin theta times 1 over this cos theta means what? Cos theta times cos theta, making it twice. So what happened? This one will cancel out what now? This. Now having 1 over what now? Sin theta times cos theta. So that's what I'm having. So what I do? I'll just get my cos theta, then I'll do justice to that. So it means this expression, what I need to get here now is just what now? Cos theta. Then it means my what now? My tan 90 minus theta all over cos square theta is this. Is 1 over sin theta times what now? Cos theta. So I'll quickly draw my triangle like I told you. Anytime you are given the ratio, you are given the value of the ratio. Draw your triangle. That's the first thing. So I'll draw my triangle. Draw my triangle. What do I have here? Theta is here. Sine is, this is what now? Opposite. This is what now? I put it on. So our opposite is what? Root 3. So I'll put root 3 here. Our hypotenuse is what now? Is 2. I'll put 2 here. So I'm looking for what? X, which I don't know. So we use what now? Pythagoras theorem. So we have what? Hypotenuse squared, which is 2 squared. Opposite squared, root 3 all squared. Plus adjacent squared, s all squared. This will be 4 equals to what now? 3 plus what? S all squared. So we now have 4 minus 3 equals to what now? S all squared. S squared equals to what? 1. What will be our what? Our x. Our s will be what now? Root of 1. S is root of what? 1. Which goes to what now? 1. So our s is what? Is 1. So what is now our cos theta? Cos theta. Cos is adjacent all over hypotenuse. So where is our adjacent? That is 1. Where is our hypotenuse? That is 2. Okay? So here we're having 1 all over sin theta is root 3 all over 2. Then times cos theta is 1 over what now? Over 2. So we're having 1 all over 1 divided by root 3 all over what now? 4. Do you get it? 1 divided by root 3 times 1, root 3. 2 times 2, 4. This will now be, where should I wipe off? Okay, let me have this place off. I think I understand the concept here. How I go to 1. So let me wipe that place off. So we move on. So now having 1 times 4 all over what now? Root 3. This will now give us what? 1 times 4, 4 all over what now? 1 over 3. So that is our what now? Our answer. Yes, option what now? Option B. Okay. I was able to solve this question because I know the relationship between what now in complementary angle. So because this one here, okay, is cos theta. So I'll first simplify the expression. Tan 90 minus theta is what now? Cos theta all over cos theta. Cos is 1 over tan, and 1 over tan is what now? Cos over what now? Over sine. So I put it there. I put this one back here, divided by this, then cos theta is cos theta times cos theta. So cos will cancel cos. I have 1 over, then I find the what now? Okay, so that is what we have under complementary angle. Do you have any other question under complementary angles? Any other question? No. So what I'll do is what? I will solve just one question under, I'll solve this question under simplification of algebraic trigonometry what? Trigonometry function. Then the next one I'll solve one question under the equation. Under the equation. So let's take the next one. Let's take the next one. Simplification of what now? Trigonometry what now? Function. Let's take the next one. Let's take trigonometric equation. Trigonometric simplification rather. Simplification. That's what two questions in South America to see. So look at this. 1990 over 4. 1991 over 40. We also simplify. Simplify. Cos square x, open bracket, sec square x plus sec square x tan square x. Sec square x tan square x. We also simplify this. So we are doing trigonometric what now? Simplification. So careful. If I want to simplify, okay, I will use my knowledge of all the things that have been taught in this video to do my simplification. If I look at this thing very well, you see that what now? Sec square theta is here. Sec square theta is here. I can factor sec square theta how? So meaning our sec cos square theta, open bracket, sec square theta plus sec square x tan square x is same as saying what? Cos square x, bring sin square x out, or it's common to both sides here. So when you bring it out, I have sec square x, open bracket, now you left with what here? 1, then plus tan square x. What did I do here? Sec square x times 1, sec square x. Sec square x times tan square x, sec square x times square what now? Tan square x. So that's what I did there. Is it clear? So let us go. What can I do again? You think very fast. What can I do again? Can I do again? Oh, look at this. Basic identity. You know we said for 1 plus tan square something must give us what now? Sec square theta. Now, if you collect under basic identity, 1 plus tan square theta equals to what now? Sec square what now? Theta. So it means 1 plus tan square s will give us what now? Sec square s. So everything here becomes what now? Cos square x times sec square x times sec square x. What can we do again? Beautiful. What is sec? Sec square x is inverse of what now? Cos square x. Sec is inverse of cos. Square x will be cos square x. So we now have cos square x times 1 over cos square x. I'll see my answer times sec square what now? X. What will happen? Cos square x will cancel out what now? Cos square x. Our answer will not be what now? Sec square x. So in the options, we are given A, tan x. B, we are given tan x sec x, tan x sec x. C, we are given sec square x. And D, we are given cosec square x. Cosec square x. And the correct answer to this question is what now? Is sec square. What did I do here? Open your eye. If you are dealing with trigonometric simplification, you must open your eye. What did I do here? I see sec square x plus sec square x. I can factor sec square x out, which is what I did here. So once I factor sec square x out, I'm left with what? 1. Or sec square x times 1 is sec square x. Sec square x times tan square x, it will give us sec square x tan square x. And this is from what now? Basic identity. Relationship between what now? The ratio, which is 1 plus tan square x will give us what now? Sec square x. What is sec square x on its own? It is 1 all over cos square x. Cos square x will cancel out cos square x. 1 times sec square x is what now? Is sec square x. So let us take another question on the trigonometric what now? Simplification. We now take trigonometric what now? Equation. And that is where we are going to end the video. So part 2 of the video, make sure you watch the part 2 of this video. And please kindly subscribe to our YouTube channel. Click the red subscribe button and turn on the notification bell. It's very simple. The reason for you to turn on the bell is this, so that when we release amazing videos like this one that I'm doing now, you get notified that we release what now? Video. Okay? That's the most important thing. The most important reason why you have to turn on the notification bell icon. Just pick all. So click the red button first, then pick all. With me and subscribe, please. Subscribe to our, and share the video. We are begging, share the video. Share the video. God bless you all. So let's take another question. Let's take another question. Under trigonometric what now? Simplification. Under trigonometric simplification. Show that this one is 1981, 81, 37. Show that sin square x all over 1 plus cos x plus sin square x all over 1 minus cos x is, we are not giving the options, A, sin x, B, cos square x, C, sin square x, D, 1, E, 2. How to solve this? What are you going to do? This is a fraction. This is a fraction. We first find the LCM. So what's the LCM? That will be 1 plus cos x, 1 minus cos x. Is that not? That's the LCM. So this one will cancel out this. I will leave it what now? This. I will now use this one here to multiply this one. So we'll now be having sec square x bracket 1 minus cos x. Then plus, what's the next thing? This one here will cancel out this one. I will let it what now? This. I will now use this one to multiply what I have. So I'm having sec square x, open bracket, 1 plus what? Cos x. If you look at this thing very well, you see that sin square x is common to both. Sin square x is common to both. So I can factor sin square x out. So when I factor sin square x out, see what I will have. I will have 1 minus cos x plus 1 plus cos x. What did I do? If I have 2xy plus xy or xy what now? Z. What is going to both sides? Xy is common. I can factor xy out. So once I bring xy out, I'm left with what here? 2 plus what? Plus z. So what I did here? I see that this times this times this. 2 times x times y. So when I'm multiplying, I can factor out. Sin square x is common to both sides. I factor sin square x out. So I'll leave it what I have here plus what I have here. Then all over, open this bracket, this will be what? 1 minus cos x plus cos x minus cos square x. Beautiful. What's the next thing here? Minus cos x, we cancel out plus cos x. Minus cos x plus cos x is 0. 1 plus 1 is what? Is 2. So I'm having 2 sine square x on top. Then all over this one here, consider this one, like the way we have this one here, this one. Now we're having 1 minus what? Cos 1 minus cos square x. So this is our answer. But this answer is not in the option, so it means we have to simplify further. But it's very interesting. Very, very interesting. So simplify further. Oh, recall that I have what now? For every sine square something, sine square x plus cos square x, I must have 1. So let me make sine square x sort of a formula. It means sine square x because what now? 1 minus cos square x. That is it. So sine square x equals what now? 1 minus what now? Cos square x. So this one is even saying what? 2 sine square x all over sine square x. Okay? So we'll cancel both sides. Cancel sine square x, cancel out what? Sine square x. Our final answer is equal to what now? So I don't want this video to be too long. Okay? So I think I'm going to stop here. Okay, please subscribe to our YouTube channel. Please just subscribe. Click the subscribe button. And if you have any challenge, you can call any of the number that you have on the screen. Okay, so I'll release the part 2 in the next video. So I'll start from what now? I'll start from trigonometric what now? Equation. That's where I will start from. So if you enjoyed this video, so kindly do us one favor. Subscribe to the YouTube channel and share the link. Okay, share the link to this video to all the platforms that you know. I'm very happy if you can do that. I wish you best of luck in your forthcoming examination. And I say thank you for watching this video. God bless you all.